Well, good morning and welcome everybody. I so much appreciate everybody taking a little time out of their day to come and talk with us. As part of our project, The Road to Zero Waste, we will be having a really interesting conversation this morning about waste conversion technologies, which we have sort of abbreviated as waste to clean energy. So we've got a pretty packed agenda, and the way this is going to roll out is we're going to have some presentations, then we're going to take a break and come back into the room and hear a few firsthand kind of vignettes that people are going to share about some activities, some energy conversion activities that are happening here in Fort Collins. So let me start by introducing myself. I'm Susie Gordon. I'm a senior environmental planner with the city's Environmental Services Division. The reason we are undertaking this master planning project is the city of Fort Collins has been doing awfully well with recycling and waste diversion, and we are at a juncture that we realized we kind of need to celebrate. The goal that was set in Fort Collins in 1999 to divert half of the community's waste from landfill disposal has more or less been met. So it's pretty wonderful. Yeah. But, you know, this being Fort Collins, of course, you know, we're not going to rest on our laurels. The City Council has asked staff to work on learning from the community what new goals ought to be set for the future and the way that we handle our waste and recycling and composting and all the other techniques that go into diverting material from landfills. So we are engaged in a process that will take us through November or December, when we'll be back talking to the council about what we've learned from the community. So again, the topic of today's discussion is waste conversion technologies. And without further ado, let me introduce our consulting team. We're really pleased that we were able to engage the services of Zero Waste Associates. They are represented today by three of the members of the team: Gary Liss, Rick Anthony, and Ruth Abbey. So these are the folks who have literally written the book on zero waste, and they have a lot of information to share. So Gary, I'll go ahead and turn the podium over to you.
Thanks, Susie, and thanks for all of you attending today. I'd like to get a sense of who's in the room. How many people here are with businesses? How about reuse companies, recycling companies, composting companies, energy companies, government agencies, schools and colleges, environmental groups, advisory boards of the city, individual citizens, academics, any other category I didn't catch? Okay, great. Well, thank you all for coming. Really appreciate it. And it's great to have a cross-section of people in the room. What we'll be doing first is a brief introduction because the goal is development of a waste reduction and recycling plan. That's our charge, is to develop that type of plan. The question is whether zero waste is the goal that we want to achieve. The council has basically asked staff to come back with a recommendation on what is the goal. Now that we've basically achieved the 50% goal, do we want to stop there and say, we're done, we think everyone's happy, and just keep it going? Or do we want to go on? And if we want to go on, how far do we want to go, and how quickly do we want to go? And that's what the waste reduction and recycling plan is about. It's being called the road to zero waste because the assumption is that whatever step forward is on that road to zero waste. Zero waste is catching on around the world as a innovative goal that most people are starting to articulate and strive for, and we'll give you some background on why that is. So we'll be talking a little bit about zero waste first, so that in each of the public meetings, this is our fourth public meeting, in each of our public meetings we want to make sure that everyone, when you hear the word zero waste, it means the same thing to you and you understand what we're talking about. So as we go into the goal setting, you can weigh in about whether you like that idea or you have some other goals that you would like to see the city adopt. So what I like to talk about in terms of what is zero waste is it's all about reduce, reuse, and recycle. How many people have heard that phrase before? Okay, it's one of the most well-known phrases in the world. And we're just saying that if you really reduced, reused, and recycled, you'd be at zero waste, or darn close. And so what's the difference between what we've been doing before and what we might want to do in the future? And it's all about focusing first on reducing and reusing, and then recycling, composting, digesting, recovering, redesigning the rest. But it's focusing on reducing and reusing, and you'll see from the next couple of slides why that's so important. The Zero Waste International Alliance has adopted a formal definition of zero waste, which has 3 components to it. That all discarded materials are resources for others to use, that don't want to burn or bury those resources, and that you want to eliminate all discharges to land, air, and water. Again, this is the goal, basically embodied in this definition is the goal of zero waste, what it means, what they're striving for. Then they go on in the Zero Waste International Alliance to describe principles and measures of performance towards that goal in zero waste business principles and zero waste community principles. And in those, they indicate that 90% diversion from landfills or incinerators and the environment is what is a measure of performance towards the goal of zero waste. So zero waste is the goal by definition, and zero emissions is the goal by definition. The measure of performance of considering someone a zero waste business or community is one that has achieved that 90% diversion. So a couple of the, slides are talking about the drivers for zero waste, and there are many reasons for moving forward with aggressive new waste reduction and recycling goals. We'll touch on some of them here. Some of our other presentations, we've gone into more detail about this, and all of the other presentations are posted now at the city's website at fcgov.com/zero waste. So if you want to look at those, those are available. But some of the key drivers are the connection between zero wasting and climate change. First of all, landfills are one of the largest sources of greenhouse gases. The majority of the gases that are produced are methane. Methane acts 21 to 72 times more potently than CO2 in creating the greenhouse effect. It acts over the 100-year horizon, which is a typical time frame for evaluating greenhouse gas reduction alternatives at a rate of 21 to 25 times the speed of CO2. Over a 20-year horizon, it acts at 72 times the speed of CO2. So it's that multiplier that comes from methane being generated in the landfill that is a real serious concern, particularly for climate change and the urgency of addressing climate change right now. In addition, we like to highlight the wasteberg, we call it. For every ton at the local landfill, there's 71 tons upstream from mining, manufacturing, and distribution of products. And that 71 tons is a calculation of looking at all the industrial waste products along the way that are produced for all the products that come to a municipality for residents and businesses to use. But that's why we can't recycle our way out of the situation. We've got to stop as much of that exploitation of the resources. We need to reuse products and packaging as much as possible, and then recycle, compost, and digest the rest. When we applied the EPA WARM model in California to all the materials that were still being delivered to the landfill, if they were composted and recycled, we found that it'd be the equivalent of taking all cars off the road. So a lot of people have heard how key transportation and climate change are linked. So this is a really good indicator how important this connection is. The methane, where does it come from? It comes from rotting organics. On the left pie chart, you'll see that of the total municipal solid waste, according to the EPA in 2007, about 2/3 were organics. And of those 2/3, the vast majority was paper. Next, big quantity in the purple on the bar chart next to it is food scraps, and then yard trimmings and some other organics. So from this chart, you'll see that food and paper are really key to getting the organics out of the landfill, not having the methane created in the landfill. One of the other things when we're looking at drivers, and it's related to climate change, but in and of itself, given the focus on energy at this session, we want to underscore that there's been long-standing analyses of the energy savings benefits of recycling. This is a chart showing by different types of materials that took from Rick's zero waste training materials that he uses when he does his zero waste training. But in general, the rule of thumb is that recycling, reuse, and composting save 3 to 5 times more energy than can be produced. So energy savings is a big factor. And the reason for that is that 71 tons upstream. So when you look at the EPA WARM model, they recognize those upstream impacts. That 71 tons is embodied in the WARM model. And that's why reuse, recycling, and composting look really good when you apply the WARM model, because it recognizes those upstream effects. So from an energy perspective, it's most important to save as much energy as you can. You may not save that locally, so this is where it gets a little bit confusing in terms of when you see what's happening in front of you, how does energy saving versus energy production work out? And the key in the life cycle analysis is whether you set the boundaries of the life cycle analysis for the solid waste system right in front of you, or for the upstream larger system approach. And if you look at just a solid waste system, producing energy locally looks really great. But if you look at the upstream, reduce, reuse, recycle is better. And that's really the emphasis. And that's why if this community adopts the zero waste goal, it would focus the community on the upstream, on reduce, reuse, recycle, compost type of approaches. The good news is that businesses are leading the way to zero waste. Large businesses, small businesses, electronic businesses, organic businesses, in urban areas, rural areas. There's a number of restaurants on here in San Francisco because they were early leaders in moving forward with zero waste, and they made it easy for their businesses to achieve zero waste, providing cheaper, easier services to move forward with zero waste. Pillsbury got to zero waste by doing 10% better each year. Xerox was an early leader for the waste-free factories because they leased out equipment. It came back as an asset or a liability. They kept putting it out there until it was no longer able to be used. They got parts from some older machines and put it back out there. When it couldn't be done anymore, it became a parts machine, and when they finally couldn't get any good parts out of it, they recycled it all. So they got the message of the waste-free factory early on. So businesses are leading the way to zero waste. And here in Fort Collins, it's the same as we find all over the country. Thousands of businesses are achieving this. Locally, Hewlett-Packard, Avago, New Belgium Brewery, Anheuser-Busch, Miller Coors, Intel, Woodward. These are all companies we've heard are at 90% or better diversion, and that's what we call a zero-waste business. Avago and New Belgium Brewery did testimonials at our earlier meetings, and in those testimonials, New Belgium highlighted they're about 93% diversion, and Avago is about 73% diversion. So they're on the road to zero waste or at zero waste, and Miller Coors highlighted their entire operation is 98.37%. GM has saved $1 billion a year in their zero waste programs. These are significant companies. Every zero waste business we've documented has saved money, reduced their greenhouse gases, reduced their liability, improved their employee morale and their customer morale, and it's good for businesses, and it's good for communities to support that. That's why communities around the world are turning to zero waste as a goal to help their businesses get all those benefits. And 125 cities in Italy just in the last 2 years have adopted zero waste as a goal. 2/3 of New Zealand cities, about 30 communities in California, and all over the country. In Colorado, we've got Telluride in Boulder City and County. Austin's been a leader in Texas, but now we have Dallas and San Antonio, so it's marching across the country. Everyone is coming to the idea that zero waste is where the progressive leaders are moving. Rick's going to then highlight some of the details that we found in our early analysis here in Fort Collins. Rick Anthony.
Thank you. When I about 40 years in this field, I'm a political scientist, so my first job was in an engineering company as a recycler, and so I got to go out in the landfill and do the first composition studies. And in the early days, we'd do, and the reason why was we were siting landfills or looking at designing waste energy facilities, and we had to know what was actually going to go to the landfill, what would be called off in the first, as we look at it, streams. And so we started, first we did 7. When I ran Fresno County, we were sorting in 15 categories. By the time we got to San Diego County, we were sorting in 54 categories. What I learned by doing this is, first of all, that I had to have a commitment up front if I was going to make a 20-year deal to bring in a flow, and I had to guarantee it as the staff that that flow would be there 20 years later. And that was, to me, was a lot of responsibility, saying to the council, oh, by the way, yeah, this is a good deal, and yes, it will be there tomorrow, not knowing. So what we did was I learned about markets. And so as I more about markets, I realized that of the 54 categories, I could get them into these basic 12 categories. So there's a 13th category that Ruth and I came up with. It's called the no market category, and it's about 10%. And it's what it is legacy stuff that was done way before and mistakes. But in our pie chart, we show that these 12 categories all have markets. The top of the pie chart, you'll see are textiles and plastics and reusables and chemicals and metals and paper. And these are facilities that are maybe not in town, but you can get money for them now because you can get them there. On the back half is the local stuff, plant debris, putrescibles, which is food, soils, and dirty paper. These are local businesses. This is jobs that can happen right here in the county, processed into soil, used for local farmers, and so they become a local commodity, and reusables are the same thing. So I take these 12 categories and I take the percentages, and the percentages were based on a 54 sort in Boulder, and then Sloan Vasquez did another analysis here. So I didn't make this up. I wasn't at that landfill looking at it, but I do trust what Cascadia did. And we break them into this categories with the amount of tons, at 137,000 tons that is generated by Fort Collins. We're not talking about Loveland or anybody else. We're talking about this city, because this is the planet for this city. And then I put a price on them. So on the upper stream stuff, like paper, you could sell all the mixed paper you want for $20 a ton. You could sell all the mixed metals you want for $50 a ton. You can. Textiles at $100, because there's brokers here who will move them to the markets. On the other one, the local markets, I got a lesser price, but these are local solutions to it. Half of what we have here are the organic materials, and the total amount that is worth in terms of, and this is very conservative, because at $20 a ton, if I had all the mixed papers, I'd sort it out into cardboard, newspaper, and ledger, and I'd get $400 a ton for my ledger and $150 a ton for my cardboard. So it's an upgrade for a processor, right? So we show over $6 million every year that could be put back into the local economy if we recover these materials. And it's probably about 500 jobs, although I didn't do that analysis. So we go look at, what I did is I looked at what was here, and then I went through your recycling manuals and your yellow pages and see if I had this stuff, could I sell it? And the only thing, or give it away. The only thing I couldn't give away was food. We don't have a place to compost food. So that's an opportunity for local businesses if we figure out a way to capture it, make it clean, and get it to our, as a distribution to the industry as a way to go. Other issues are listed there, things that we need to work on. A lot of these are materials that producers should be responsible for, like paint. Upstream, so the new way is not integrated waste management. It's not waste anymore. These are commodities. It's markets. So when we look upstream, that is before you throw it out, we want to run a clean factory and basically cover everything, get everything recycled, and actually redesign our product so it doesn't end up in the landfill, but ends up in a recycling stream, and take responsibility. Downstream, at the city level, at the hauler level, it's about reduce, recycle, and compost, and cleaner energy if it's cost effective, and certainly for the self-hauled, the ability to take it to a place where they can put it in the right place. We call these resource recovery parks. This is an example of a resource recovery park that we designed generically in England, and you can see on the inside, you could run through the park and drop off in all the categories. On the outside, the trucks are picking up finished materials, and outside the park are all these industries that are created to deal with this, like appliance repair, sofa repair, things like that. What we're doing right now is talking about this last part, the residual part, the stuff that we can't get or don't get or haven't got, maybe want to get. And we want to know, there's some pilot programs, there's smaller facilities, or there's an anaerobic digester at the sewer treatment plant. So there are some waste energy facilities. How are they working? What do you think is needed? And what role should the city play in expanding these facilities? Should they fund them or should make them merchant facilities? If they're cost effective, they ought to be able to run them by themselves without any dedicated money. We could talk about all those. And then the last piece is this is our process. It's a 6-month turnaround, very fast. We've been here twice, a lot of public meetings, talking to everybody. I don't remember your names. I remember your face. So we've been at the council. We've had the stakeholders meetings. We did reuse and recycling. We've done composting, and today is the cleaner energy. We're going to come back in August and talk about our policies and programs. And in September, we'll have a draft plan. And we want all you people that have come to all these meetings to show up at the city council. Hopefully, we will reflect what you think is the right way to go and build a consensus. The council wants a timeline. They want to know about costs. So help requested. We want you to identify issues that you'd like addressed. We want you to help ID other stakeholders interested in waste reduction, reuse, recycling, composting, product stewardship. Help promote the zero waste plan process and engage everybody in the community. A lot of you are stakeholders. You have a vested interest. Tell your friends. Let's get the regular homeowner who's going to be subjected to any rules we come up with. Let's them come out here too and understand what we're trying to do. Pursue it at home. Be a model of a zero waste in your home, and then take it to your job, your church. When you do a zero waste wedding, tell people what you did. So here I want to it's a talk among yourself. It's an intellectual question. If you're not for zero waste, how much waste are you for? Thank you.
Great, thank you, Rick. Our next speaker is going to be Ruth Abbey with HDR Engineering. Ruth has led a number of zero waste projects that we've participated on. She's also been sub to us on other projects. Her firm has done extensive analysis of waste energy issues, taking tours around the world. She didn't invite me on those, but I don't really like to travel that much, so that was okay. But HDR has done outstanding work in analyzing the technologies around the world that are available, seeing them firsthand, close up, and trying to put them into perspective for communities looking to pursue zero waste. So here's Ruth Abbey.
So today we're going to talk about waste to energy. My firm does a lot of work in the waste energy field. It's an engineering firm, and we assist communities all over the country and all over the world in procuring new technologies, including different types of waste to energy. My work is primarily in the zero waste arena. I work with communities to plan and implement zero waste programs and procure zero waste facilities and infrastructure. So today we're going to kind of talk about, in generic terms, what is waste to energy, what do we mean by waste to energy in this discussion, and what do we as a community feel is the role of waste to energy in our future. So what is waste energy? For today, we're going to say waste energy is any technology which recovers energy from the management or processing of discarded materials. Waste energy as a term sometimes refers to mass burn technology. That's not what we're talking about today. That's not the only energy from waste opportunity. We also sometimes hear the word incineration. Incineration is sometimes used to refer to mass burn facilities. Incineration is also used to refer to facilities that don't recover energy from waste. But today we're going to kind of use the broad umbrella term waste to energy and talk about what kind of technologies fall under those terms. So waste energy includes the thermal technologies. And the most prevalent thermal technologies in this country and around the world is mass burn or burning of refuse-derived fuel for energy. There are over 80 facilities of that type in the country, and those have a long history of performance. They are essentially power plants that use trash as a fuel. There are emerging technologies that are thermal-based, and we're going to have a presentation in a few minutes from a technology vendor to talk a little bit about their technology and their observation, but essentially the difference between these technologies is in how they perform and what the process includes. So I talk about them as being emerging technologies: gasification, pyrolysis, plasma arc, gasification. I talk about them as being emerging. They're emerging as applied to mixed municipal solid waste. These are not new technologies in the industry. These are not new technologies in the world. We have been gasifying things forever. So to talk about gasification for a minute, gasification is the process where you heat materials, which then form a gas, and then the gas is burned for energy or can be collected for fuel. This concept can be used to produce charcoal. It's what you see when you have a fireplace. Your fireplace is essentially a gasifier. It heats the log. The log gives off a gas. The actual thing that you see burning is not the log, it's the gas. And that's why at the end of your process you get a charcoal log or a burnt log or ash. So that's the concept in layman's terms for gasification. And then the different types of these processes include other additional higher intensity heat, and then different residual materials that come out of the back end. And I'll talk a little bit more about that. Some of the other differences between a mass burn, direct burning of trash, and gasification or pyrolysis or these other materials is that because it is a two-stage process, you have the opportunity to capture that gas, which is a synthesis gas, and then burn that gas or create a fuel. There's the potential to have reduced emissions because it happens in an oxygen-starved environment, and so there's a potential for fewer emissions, although all technologies that burn create emissions. So that's essentially the thermal technologies. We also have chemical technologies. Again, these are emerging as applied to trash or applied to materials derived from trash. Biological, we'll talk a little bit more about anaerobic digestion. Digestion is the process, is a biological approach where material is broken down by microbes in an anaerobic setting without air, and then that also produces a gas. It produces a biogas that can then be burned for energy or made into a biofuel. Again, anything that burns something will create emissions, but because it is a biological technology, there is potential for fewer emissions. And then there are combinations of facility types as applied to solid waste management that include mechanical biological treatment. You first separate all of the materials, take out the recyclables, and then you anaerobically digest and treat the rest and derive energy from the fuel. Or a new term we call material recovery biological treatment, which is a really intensive process of taking out more materials prior to treatment in the process. And then there are also emerging technologies of, again, creating fuel from the synthesis gas or the biogas that then could potentially be used in fleets of trucks. These are not demonstrated, these are not common around the country, across the world, but these are things that are emerging and many communities are very interested, and Karen will be talking in a few minutes about some of the communities that are looking at these technologies. Just a bit on the comparison, direct combustion of trash versus gasification, plasma arc, pyrolysis, thermal and catalytic depolymerization, anaerobic digestion, and hydrolysis. Essentially, I wanted to just show you the primary processes. Direct combustion produces heat that then is used to make steam. The steam is then used in a combined heat process to make energy. The gasification, as we discussed, creates the synthesis gas that is then burned to create energy. Plasma arc, very similar to gasification, but at a higher temperature, as is pyrolysis, which Karen will be talking about in a minute. These are smaller scale units. So these other kinds of technologies, these staged technologies, are more modular in their nature. There is typically in the mass burn technology, you're looking at very large facility, 500 tons per day to 2,000 tons per day, although there are smaller modular units, 250 tons per day. These other technologies can be produced at smaller scale and more modular. A little bit more about the anaerobic digestion. Again, as applied to solid waste, this is an emerging technology, but we have been using anaerobic digestion for biosolids in the wastewater treatment plants for decades. And our wastewater treatment plant in Fort Collins uses this technology to process biosolids, to actually process wastewater to create a biogas that they then burn for energy. The result of the digestion process produces a digestate that we call biosolids. It could also be called a sewage sludge that then is land applied on dedicated lands that the city retains. And then hydrolysis being more of a chemical process that has the potential to create ethanol. This is another emerging field, and there's a lot of research on waste to ethanol, waste to fuels, using other kinds of feedstocks such as switchgrass, agricultural materials. This is, again, something that is being studied as a potential future to replace other forms of energy creation. And then I've talked a little bit about, the stage of development and whether we are at a commercial scale. Here is just a picture of a couple of different thermal technologies using the mass burn technology. As I say, these have been in existence for several decades around the world and across the country. They are larger, 500 to 2,000 tons per day. The cost per ton is pretty substantial. We are working with communities that are looking at 120 to 200 tons per day, per ton of cost. This is probably the most significant issue about new technologies or applying waste energy technologies to our solid waste, because landfilling is relatively cheap compared to waste to energy of different forms. Some of the older facilities have tipping fees under $100, $50 a ton, $60 a ton. This is largely dependent on what they can get for the sale of their energy. And in some states, the energy derived from a waste-to-energy facility is considered renewable energy, and they can get a premium price for that. But on a state-by-state basis, there's a difference there. And then it also requires a lot of space, 5 to 15 acres we're talking about. The non-combustion thermal technologies we talk about as being non-combustion because the trash itself is not directly burned. It is heated to then derive a synthesis gas. These technologies, again, are smaller scale, but can also be very costly. Because these are emerging technologies applied to solid waste, we do not have a lot of examples of facilities that are up and running that we can point to and show you, and that we have contracts in place that can tell you what the costs are. And this cost range is based on our analysis of proposals that we have reviewed on behalf of communities across the country. In addition to the energy that is produced from these types of facilities, there are also potential other byproducts. Produced out of a mass burn waste to energy facility is an ash, and the ash is sometimes considered hazardous and must be buried in a landfill, a hazardous waste landfill or a monofill. In some communities, particularly in Europe, they are able to separate the fly ash from the ash coming out of the waste energy facility and reuse that ash. For these other technologies, because of the high heat applied to the materials, they are able to make a glassy substance that looks a little bit more reusable, or is potentially more reusable. And so that's some of the byproducts that are potentially available to be used out of these kinds of technologies. And then on the anaerobic digestion, which again, not a new technology in the world, but a new technology as applied to our material streams that we're talking about. Again, in a wastewater treatment plant, very common in a confined animal situation for manures and other things. Again, quite commonly used. But as applied to trash or source-separated organics, food scraps and other materials, this is an emerging technology. And again, these facilities can produce a biogas that can then be used for energy, and then the digestate coming out of an anaerobic digestion facility can then be either further composted and used as a soil amendment, or it can be land applied, depending on what the feedstock was to the facility. Here's a quick status, and then Karen will be talking a little bit more about in other communities. These are just some examples of some different technologies that have been developed around the country in the last few years. Plasco, which is a facility in Ottawa, Ontario, Canada, is a plasma arc demonstration facility, and that has had started up in 2007 and is kind of still in the testing stage. The idea is to demonstrate this technology for mixed waste and also for high BTU value materials such as mixed plastics. Enerchem, which is a project in Edmonton, Alberta, Canada, is a gasification project that will be used to create a methanol and an ethanol product, and that is under development. The operations are scheduled to start this year, and then the production of fuel in 2014. The Durham York Region Energy Center is a new mass burn facility. Because of some controversy around mass burn technology, we haven't had new waste-to-energy mass burn facilities cited in this country in the last 20 years. This is the first waste-to-energy facility using mass burn technology that has been developed in the in North America in the last 20 years. So we call it a greenfield mass burn facility, and this is the first one that has been developed in 20 years in North America. So that's kind of significant. And then H-Power in Honolulu, they have recently added to their RDF facility a new mass burn unit to expand their capacity. Their Dufferin Organics facility in Toronto, Ontario, Canada is also a demonstration facility that has demonstrated source-separated organics to energy. It produces a biogas out of the digested organic material. The digestate is then used to be further composted. And what they like about this technology in Toronto is that they are able to produce anything that is digestible. They are able to process anything that is digestible, including food scraps, but also they process diapers, pet waste, everything. And so they really like this technology because it is a complete package for them for the organic material. And then a new facility that is coming online next year is the Zero Waste Energy facility in San Jose. That will be the largest anaerobic digestion facility for source-separated organics to be developed in the U.S. As an emerging technology, this is truly at the commercial scale. It will be 200 tons per day, and the construction is scheduled to be completed next year. There are several potential benefits to waste-to-energy, the umbrella of technologies that we're talking about. Processing our waste before disposing it, our mixed waste prior to disposing it, reduces our reliance on landfilling. And some of the technologies can actually reduce greenhouse gases compared to landfilling. They also have the potential, some of these technologies, to recover recyclables and compostable materials prior to entering the process, the technology, and some facilities create energy to reduce our reliance on fossil fuels, and so you can think about it as an opportunity to switch out our dependence on fossil fuels for other technologies. Some also recover chemicals and other byproducts, and this is a way of, if the facility is located in the city or in the vicinity, it's a way of treating our waste locally rather than exporting it to other communities that have to have those impacts of a waste facility. And that's just very quickly, there are also some potential impacts associated with waste to energy that I wanted to make sure we were all talking about, including all facilities that combust waste or combust gas have emissions, including things like nitrous oxides, sulfur oxides, particulate matter, and toxic chemicals, including dioxin and furans. The level of emissions can be significantly reduced through technology, pollution control technology, but we can't get to zero. And so depending on a community's tolerance for emissions, this is an issue that has to be raised and has to be discussed. And then any new technology facility obviously would go through a very lengthy review process, including environmental assessment, health assessment, to make sure that any technology that was chosen was appropriate for the community. And then, so just a couple other additional considerations. Number one, I think, is cost. I think what we are seeing across the country, that as compared to landfilling, most new technologies and commercial scale technologies are more expensive than landfilling for our residual waste, and more expensive as compared to recycling and composting. The feedstocks are really important. I've talked a lot about mixed waste feedstocks, which is the primary focus of a lot of these technologies. But there are special feedstocks that may be very appropriate for these different technologies, depending on the community and the community needs. So, for example, treated wood that cannot be composted and cannot be beneficially reused in other ways, it might be appropriate to gasify treated wood to get the energy benefit from that wood prior to landfilling. A new facility in Honolulu is being developed for treated wood. And then there may be other things like source-separated organics, plastics that can't be recycled, that are specialty cases that may want to be considered for demonstration or for special technology assessment. And then I think the most important thing for us in working with communities is the business structure, the risk allocation, and the financing. There have been a number of proposals, and Karen will talk to you about that, of technologies across the country, emerging technologies that have communities had looked seriously at, but couldn't move forward without the business relationship and the allocation of risk, particularly around whether they can get renewable energy credits and can get the financing for that, whether they can compete with natural gas to sell it and get that benefit. I think that what happens is, because right now we are in an era where natural gas prices are very low, it is very tough to compete against natural gas when you are producing a biogas or a synthesis gas. And then we need to be completely transparent in our conversations about new technologies. I think there are fears about new technologies. There are issues that need to be discussed and elevated, so we can't kind of sugarcoat it and say it's no problem. We don't want to say no emissions, no stack, and we pay you for the garbage. That's not the message. The message is we have to very seriously consider what's appropriate for our community and how these kinds of technologies fit in. And then lastly, for any new development, and I think you all know this living in the community, for any new development that is potentially controversial, it requires a political champion. It requires folks to get behind it. And so that's something that I think that we would need to identify moving forward if this was the direction that the city was going to choose. So.
Great, that was a really nice overview, Ruth. I know this can be a very complex, highly technical discussion, so thanks for everybody for hanging in there. And for that reason, I'm very pleased to introduce Karen Bertram. Karen is with a company called Integrated Energy Services. And we met Karen earlier this year. Ginger Purvis and I had a chance to talk to her. Ginger works for Light and Power Utility, and we were struck with how much firsthand knowledge Karen has about traveling around the country and working with communities of all sizes to talk about this type of technology and what kind of fit might work for them. So I'm going to go ahead and turn this over to Karen, and just let me acknowledge also Kip Funk is here, her colleague. Karen, why don't you come on up and tell us all about your experiences. Thanks.
Hi, I'm Karen Bertram, and we're Integrated Energy Services, and we are a technology provider. So as Ruth was discussing all the technologies, I have direct experience as a technology provider. And the categories that she talked about, we are pyrolysis. So Integrated Energy Services has its own technology, although we work with other technologies for seeing what fits in a community. The way we became introduced to Fort Collins is there was an initial RFP, or request for qualifications, and we submitted a proposal or a thought that we thought our technology might fit in Fort Collins. But we've done a number of other technologies. So I'm doing an introduction, but we work with a number of companies. Kip Funk, who's also part of Integrated Energy Services, does all of our engineering and our engineering design. And we also work with other manufacturers and companies like Siemens to introduce our technology into turnkey projects. We also have a lot of experience. We're a California company, so everything that we've done, our demonstration plant was done in California. I used to be with a company called International Environmental Solutions and was the original patent holder, and we have developed an upgrade over my last 12 years. We've actually upgraded the technology, so I started this 12 years ago, so it's been a reiteration. And because of that, I have a lot of experience with the stringent permitting policies. And so that's one of the reasons why we have decided to look at communities like Fort Collins as opposed to Los Angeles. There's a lot more large communities that are doing the thermal conversion technologies, but there are a lot of communities like Fort Collins that want to do road to zero waste and use thermal technologies, but they have a lot different economic profile. So I'm going to introduce Kip, and he's going to go over a brief little summary of what pyrolysis is and how we plan to implement these in communities and what projects we're doing.
Hi, I'm Kip Funk. My company is Funk's Engineering. We're out of Littleton, Colorado, and we're primarily focused on engineering consulting, high-level feasibility studies of waste energy type technologies. We've performed these types of feasibility studies for Department of Defense, for Department of Energy. I've worked with HDR in the past, Ruth's company over here. And we're also focused on power generation. And that's where Karen and I were introduced and this whole partnership is formed. So what is pyrolysis? The technology that we are actually presenting to Fort Collins today is pyrolysis. And it's a thermal conversion technology. It's not incineration or combustion, which produces a lot more nitrous oxides than what we're actually generating. Pyrolysis is the thermal conversion in the absence of oxygen. So there is no combustion going on in the waste stream whatsoever. We're generating the syngas. The syngas then is separated and combusted downstream of the thermal conversion piece of equipment. Pyrolysis it's been used over the last 100 years. It's been used in charcoal generation and converting coal to coke, and we're actually taking the technology and reintegrated it into a social problem that's been noticed throughout the world, and that's waste. We're working directly with companies out of India, trying to help them manage their waste programs, because I don't know if you've seen pictures, but in India there's waste streams, or there's waste all over the streets. Different materials that actually you can utilize pyrolysis for. Municipal solid waste, which is what we're talking about here today, it's one of our primary focuses, but waste tires, waste woods, the beetle kill here in Colorado is a big issue. Construction debris, or auto shred residue, which EPA really doesn't know what to do with it. They're allowing it to go into landfills right now, but we can actually utilize that as a waste stream, as a feedstock stream for pyrolysis, and convert it to power as a useful byproduct. Our systems these are a couple different examples of general layouts of what our systems look like. This is specific to a project we're doing for Department of Defense right now in Fort Irwin, California. We're working directly with Siemens. The interesting thing about the Department of Defense and a military base is it's really like Fort Collins. It's a small community. They generate a very small waste stream. And we're trying to integrate our technology and bring the costs down so a community like this can actually a project can actually pay for itself without the community really having to pay tax dollars towards that application, which is truly the case at Fort Irwin. A typical plant layout, because the thermal conversion piece, the pyrolysis piece that we're talking about, is the very first piece of equipment in the train of the whole power generation facility. That's where we're taking the MSW and actually converting it into a syngas. Once we convert it to a syngas, we combust it. We collect the waste heat off the combustion of that syngas only. And by combusting the syngas, we can actually minimize how much oxygen we're inputting into the system, which minimizes how much NOx emissions are going on. And of course, downstream, we have the latest technologies in scrubbing those emissions to make sure that we're emitting as little emissions as possible. Benefits of pyrolytic conversion, it's a modular system. It doesn't have to be constructed on site as a big building. All the pieces are built off site, delivered, bolted together. It's a quick and simple installation. It doesn't matter what the feedstock looks like, as long as it's a carbon-based material, we can actually convert it into an energy source, whether it's fuel or power. Typical power output for a facility like we're talking about is between 1 and 2 megawatts. This is very specific to Fort Irwin, what their generation was going to look like.
And so what we're looking at with the project is very similar to what Ruth was saying on her slides, is that you need to look at a lot of different factors as you're looking at that, the economic feasibility for the city, the siting, determining where it's going to be sited so that the public's happy, you have the project structure, project design and performance, and you look at the sustainability goals, which are also included with your recycling and all of the other programs that you have, and then the operations and the marketability of the products and environmental impact and permitting. And some of the slides that I'll be going over, Ruth also did, but I'll just kind of skip over those as we go. But one of the main things is to look at how many communities in the U.S. are starting to do this. She showed some, a lot of them were in Canada, and a couple were in the U.S., but this is only a tip of the iceberg of how many communities are looking at. This year, or last year, New York City put out a large RFP, Waco, Texas, which put out an RFP in March of this year. City of Los Angeles and the County of Los Angeles have been doing this for a number of years. Trying to get commercial demonstration. A lot of the intelligence on what's being happening all over the world has come through the money that County of Los Angeles has done in their commercial demonstration project. San Jose, California, which of course Ruth pointed to. Maui, Hawaii just selected a technology. Their RFP came out in December of 2012, and they've already selected a technology. Maui is going with the digester because the power company didn't coordinate with the county on the landfill. They didn't want to buy the power. They said, oh, we'll buy a peaker plant. Well, that doesn't pencil out economically, so Maui went with the digester so that they could do a gas project. So, and the utility came out with its own RFP. So the two agencies did not match, and you had competing RFPs, which really doesn't help get the project. But this is at least their first step, is to use a digester to at least take care of some of their waste. Greensboro, North Carolina came out with an RFP, but now they're going to restart over. So they didn't know where to go, so now they're going back, hiring consultants to say, well, we didn't do it the right way. We tried to do it ourselves, but we don't have enough education to decide what to do. So Fort Collins started the right way, so we don't make wrong turns. Hire someone to tell us how we need to go to make it more cost effective so it doesn't cost Fort Collins more money. And Fredericksburg, Virginia, just in the last 2 months, that one has been, the lease has been approved for a plant in Fredericksburg, Virginia, for a technology, and it just so happens it's pyrolysis, but it's a technology from out of the country. And Fredericksburg, it's actually Stafford County and Fredericksburg own this landfill together. So Stafford approved the lease last year, and the city approved it 4 days ago to a unanimous vote to do a project at their landfill. Now, Fredericksburg only has 270 tons, so they need to do 360 tons to make it all work for the technology, so they're going to bring in other waste from outside to make up that difference. The city's going to get $1 million up front on the signing of the lease, which will be in a couple weeks, and $100,000 every year as an annual rent that goes back to the city to be able to do this, and they're paying for it. So it's a build, own to operate by the technology provider. So there's no cost to the city, and actually they get some benefit, the $1 million up front and the rent for the 20 years of the project. And Santa Barbara County, I specifically was on the short list for Santa Barbara County, that's in my California area, and there were 3 thermal technologies. Plasco was one of them, as well for the plasma arc, and another technology, but they chose a digester. And the reason they did, and the article said that they really wanted thermal, but because of the political climate at the time, which was a year and a half ago, it's easier to permit a digester. They also have the Coastal Commission, they're right there, and they had a limited amount of water. So they went with the digester, so their hope is to do a digester with a gasification or thermal process behind it, but take baby steps because of the public perception and the cost for permitting. In California, that's in South Coast Air Quality Management District, extremely hard for, well, it's north of that, but extremely hard for permitting. Permitting may take you 2 or 3 years. So, and then there's more cities, like there's a new RFP that just came out for Vancouver, and they had a short turnaround, and out of 22 technologies, they have already shortlisted 10. All of them, except for one, is mass burn. And the one that's not mass burn is taking the trash and putting it in a cement kiln. So it is actually mass burn, but they have 3,000 tons a day. So they're looking at technologies that have a history. But all of them, San Francisco is also looking, but they also have done digesters. And Hurlburt Air Force Base has done plasma arc. They have a functioning 10-ton a day that's been there for 3 years. But that's all the waste that's at that base in Florida. And you'll see a lot of Florida up there because Florida creates 3 billion kilowatts annually from waste to energy in Florida alone. They're the #1 state to do that. And St. Lucia was going to use plasma arc, but last year they changed after going back in 4 years. And so now they're going to go out and resubmit because even though they didn't choose the technology that they'd been working with, they still know that thermal conversion technology is the best for them. But a lot of these projects are not like Fort Collins. Fort Collins has a small amount of waste, especially if you're going to do your zero waste initiatives, because the only waste that's going to go in this plant is after reduce, reuse, recycle, then recover. So it's actually the last step on your road to zero waste. So it's whatever's left that can't be sourced anywhere else that's going to go in there. So that's going to be something like 70 tons or maybe even less based on some of the great numbers I saw earlier. So there may be less than 70 tons after this is all done. And the good part of that is that means that you'll be so close to zero waste. And it also will do some other great factors. Your landfill that's going to close in 15 years is probably the only landfill you'll ever need. So you don't have the permitting, the opening and closing of a new landfill. So now you've extended the landfill that you have by 100 years. You don't have any more things going in the landfill that are going to create methane because using the thermal technology, whether it's pyrolysis or any other technology, the methane that we saw that was so toxic is gone. And so, so the challenges that Fort Collins has is that you are going to do so well on your zero waste initiatives, you're not going to have that much waste. So now we have to see how that's going to economically do that. In the large communities, 3,000 tons a day with a tipping fee of like you said, $100 or $89, like Santa Barbara. I bid on that. Their average tipping fee is $80. That's a lot higher than what Fort Collins has. And they also, so a lot of regions are going to have a considerably higher. In the Northeast, they have a $100 tipping fee, or in the range of $69 or $60 is the lowest you'll see. So now we have to look at that as we're processing. But when you have a large volume of 3,000 tons a day, even if you have $30 a ton, that's a lot more money than something that's $70. So we have to work on how we can make a thermal technology work with the economic variables like the cost of energy and the tipping fee, which is so low in Fort Collins. And as I tell people, one of the things we want to focus on with our modular unit is we can build a small unit that's efficient enough to be able to do that, the same way we're doing with Fort Irwin, California. They only have 32 tons a day, as you saw up there, but they pay a lot more for the waste. It's a military base. They're in the middle of nowhere. So logistically, they're going to pay 13 cents per kW, but they're also in Southern California, Edison. They're paying a lot more for energy than the 13 cents. So they're doing this as a way to be security and energy dependent. And these are initiatives at the military. You saw on my list I had Fort Hood, Fort Bliss. Fort Bliss is going to take the waste from El Paso and use the community's waste to become independent at that base. Dyess Air Force Base was doing the same thing, taking the waste from Abilene. And so you see the different communities. Now, if you did a little bit more of a regional, you might have some others that you might consider where Fort Collins owns part of the landfill, but so do others. So perhaps doing a regional, you might do something, and maybe it's around 100 tons a day, which then could start to be more favorable. Electric costs, natural gas right now is making some of the electrical costs not go up, but in a lot of states, 26 states consider technologies like this renewable, at least a large fraction of the waste. So those have to be considered, because if you get a premium for your energy, that could offset the cost of the tipping fees. But one of the things with waste to energy, it stabilizes the tipping fees over a long period of time. You're not going to see these large spikes as costs go up. So what we look at is the economic feasibility, but also the lack of public awareness on the benefits of waste to energy. So these nice community sessions start to give us an idea of how this is going to help the community and the road to zero waste. The policy and regulations make it more difficult to permit in some areas. Well, that's changing too. All of the legislation, the EPA, everyone says that waste to energy is the best thing over landfill. They actually now have the new hierarchy. He asked if we knew about the 3 R's. Well, there's actually 4. It's reduce, reuse, recycle, and recover. So that's what Europe does. They say that recovery is ahead of landfilling. So the EPA says it's the cleanest, most efficient way. We have all of these bad perceptions of incineration or mass burn, but they can't get permitted if they do not meet the standards. And of course, the EPA, we have where you have the best available technology. Well, now there's the new MAC rule. You know, the new MAC boiler rules are really affect everything, because that follows down to the community. So communities that follow the EPA rules and guidelines now have more stringent policies for those pollution controls. So they spent billions of dollars upgrading the existing waste to energy that we currently have, which is only about 86 facilities. Europe has 460 facilities. Japan diverts 63% of its waste to waste to energy. The rest of it, they recycle. So, and then we've got the financial risk is directly tied to the economic feasibility of the project. But we have the public concern for environmental impact. A number of the cities that I mentioned, New York City, in their RFP, they will only look at conversion or new technologies. They said ban no incineration. So incineration is not even a technology they will consider in New York City. There is Waco, Texas, said they would consider incineration. However, they would have to go through an expensive evaluation and health risk assessment for the community before they would even sit to consider them. So they would have to do a health risk assessment. So the communities that are considering mass burn are actually putting some restrictions on that they have to make sure that there is not an issue with that and that the community will then be okay with. And then, so that's where we come up with the frequently asked questions every time that I talk to anyone, is that, you know, are they safe for the environment? The answer is yes. And these questions all came from the EPA. So the waste energy facilities produce electricity with less environmental impact than almost any other source of electricity. That methane that they talked about is a huge problem. But with these technologies, there's 0 methane. So now the landfill gas that you were getting by putting in the landfill is now gone. There is some CO2, however, there's a lot of reduced emissions. It's 2/3, 3/4 less than what the landfill would have generated. And how do these affect the greenhouse gases? I think that's the same question. The life cycle shows that 1 ton of CO2 equivalent for every ton of trash is reduced by doing it into a thermal technology, whether it's pyrolysis or plasma arc or gasification. And waste to energy is a renewable energy source. It is in about 26 states. Now, not all states have a renewable portfolio standard, but Colorado is one of the renewable portfolio states, and there's new legislation always changing. California, they go back and forth on certain technologies. In Europe, pyrolysis, I know for a fact, gets 2 renewable obligation credits for over other technologies because it's innovative. And then, does processing MSW of waste to energy compete with recycling? The answer is no. Every community that does waste to energy actually went up in their numbers of recycling. Because remember, when you do a waste to energy, you actually will be able to get all the recyclables that were in that trash, like broken glass, metal, ferrous and non-ferrous metals, are not processed. They come back out in the discharge, whether it's a carbon char residual or an ash. So currently, we get over 700,000 tons of ferrous metals every year from the waste to energy plants. Actually, it's cheaper than mining and actually has a better sustainability goals than mining. So you have over 700,000 tons of metal that comes out. That's not even including the non-ferrous. So some of these same impacts were the same exact ones that Ruth discussed. So we had very similar ideas of what waste to energy could do for a community. So we both talked about the same positive impacts. And you have jobs. Every one of the things that you see when you talk about these cities, they all had 70 jobs on those large ones, or jobs for about 30 people. So there's jobs that are ongoing for the 20-year life of that project. The renewable baseload, renewable energy goals, the reducing the methane, and also the economic benefits of selling the metals. So the recycling, you'll be able to sell the metals and things like that. So, and then just the key implementation steps, similar to what Ruth was talking about, where you kind of decide how you want to proceed. And, but this is a long process. This doesn't happen overnight. The public needs to be aware of this, and you also have to look at every variable of the community and work with all the programs that you're putting in.
We have a couple of local speakers to talk to you today. Link Mueller is here from the city's water utilities. He's a special projects manager, and he's going to give us a very brief preview of what's going on with the pilot project involving some pulped food material from the CSU dining halls. Link, you want to take the podium and just, again, this is very informal, folks, and we've got a couple of other speakers, so I promised Link I wouldn't, we won't grill him on this, but it's sure interesting to hear about this project. Thanks, Link.
Thanks, Susie. Just kind of as a historical perspective, Fort Collins Utilities has been doing in the anaerobic digestion business since 1946. The original wastewater plant at Mulberry has had 4 small digesters and a small boiler that they use to heat the anaerobic digestion process. In the 80s, it was decided that we'd consolidate the solids handling, as we call it, at the Drake wastewater reclamation facility at the end of Drake Road. Currently, we have 4 anaerobic digesters on site, and we utilize the methane that's produced off of there to heat the anaerobic digestion process. And at this point, we also have heat exchangers with a glycol loop that heats approximately 2/3 of our campus. So we do utilize the existing methane gas, and we, we're kind of in the anaerobic digestion business. It's already here. We already maintain it. We already deal with the odors, which is always a big issue when you're dealing with food waste. So it's there. We're looking at putting together some more proposals for City Council on some commercial food waste receiving, if that's something that they desire to do. Another option besides food waste is fog, fat oils and grease. Some of the research that we've been doing around the community is it's kind of hard to get the nice grease, the yellow grease. There's a lot of companies out there that are going around and collecting that and utilizing that to produce biodiesel. But there's not a lot of interest in the black grease, and our digesters kind of don't care. The microbiology will handle that just as easily. So those are the types of things that we're kind of positioned to be able to help out with as far as the solid waste reduction. One of the pilot project that Susie had mentioned that we're dealing with is we're working with CSU. CSU's in the process of upgrading all their cafeterias. As they move forward with upgrading their facilities, they're improving their waste diversion. And they take their post-consumer waste, stuff that the students leave on their cafeteria trays, and they put it into just a big incinerator, and they grind it all up, and then they send it to a dewatering system, and they dewater it, and it ends up in these pulp food waste containers. They do have a composting facility at the west end of LaPorte that they were taking this material to, but they kind of found out that they were producing a lot more than their facility could handle. So last year they came to us and asked if there was any way that we could integrate this pulped food waste into our system. It just so happens that since we don't have a commercial receiving station for food waste, let me back up. Typically, a wastewater plant, if you're set up for food waste receiving, what you're going to do is you're going to receive this material, it's going to get ground up, it's going to strain out the trash, and it's going to put it directly into the sludge loop right to the anaerobic digesters. We don't have that on site yet, so we really can't handle community waste at this particular point in time without something like that. But the fact that CSU is already pulping this material really kind of helped us out there. And so we decided with CSU we'd go ahead and try this out. And since February, they've been sending us approximately between 800 and 1,000 pounds of pulped food waste. And it's their post-consumer, their pre-consumer waste that they use, that they produce when they are preparing the food is still going out to their composting facility out on West LaPorte. But as far as everything that's slurried, it's coming to our facility. Our operators basically put it into the system just prior to the primary treatment. And because it's such a small volume in relation to what we can handle, haven't seen a major increase in our gas production, but we haven't seen a disadvantage to receiving this waste either. So I think it's been kind of a win-win. We can help out CSU, and they can, it's helping out the city's diversion rate. So that's kind of where we're at right now.
Yeah, so this is a brand-new project for the city and CSU, and really great work. I'm going to go ahead and introduce Stacy Baumgarn from CSU. There's another project going on at CSU that Stacy's going to describe, and he's kind of standing in for Carol Dollard, the CSU's facilities engineer, but she wasn't able to attend. Stacy, I really appreciate you being able to come and just give us a thumbnail sketch of this project. Thanks.
Great, thanks. Thanks. So I'm Stacy Baumgarn. I'm the Campus Energy Coordinator over at CSU, and I was asked to talk a little bit about, we have a biomass plant out on the Foothills campus. So this is a project that was built back in 2009, and it was evolved out of a partnership. Actually, the Colorado State Forest Service came to CSU and said, hey, we would like to do something with some of this wood chips, biomass. So they had a grant that kind of put some initial seed money, made the kind of incentivize the project, and we thought, hey, it'd be a good pilot, it'd be a good learning demonstration opportunity. So we built a plant, and so we put some money in, they put some money in, and that's how it came together. So at the time that we built the plant, wood chips were about half the price of natural gas. So we've already heard about the price of natural gas. So obviously at the time that we said, yeah, let's do it, the economics were pretty good. Today, with the price of natural gas being so low, and it's kind of a small plant on the scale of things, so you have a fixed labor cost. So you have, anyway, the economics aren't as wonderful today, but it's not bad. And so we still think it's a good project. The plant provides space heating. It's a thermal plant, right? We just make hot water to provide space heating for one of our buildings. It's only providing about 5% of the required space heating. So in one sense that sounds really low, but what's nice about it is it means there's always demand in that building for that amount of space heat, which allows us to run the plant kind of most optimally. And you can always kind of run it at its most efficient state. You're always providing that amount of heat, and it's always being utilized. So in that regard, it's kind of as good as it is. It's really a good situation. So the wood chips, where do the wood chips come from? Wood chips come from different forest thinning projects, or obviously we had a lot of beetle kill in the area. So you can clear that out and chip it up, and it makes perfect fuel for the plant. Just put it in scale, I guess. We utilize about 460 tons a year. So, a little more than a ton a day, even though we're not running every day all year long. But anyway, That's about 50 acres. That's about, if you'd process or kind of take care of about 50 acres, and we're not talking about clear cutting, right? We're talking about using those beetle kill and forest thinning. 50 acres, well, what was the Hyde Park fire? Just under 90,000 acres. So you can tell, like, we're kind of not moving the needle on what our available resource is, or if we'd have been able to, you know, there's a lot of resource out there to be used. So anyway, and I want to just touch on the emissions factor, because we've talked about, of course, there's emissions from biomass. When you use wood chips in a biomass plant like this, you're about 96% fewer emissions than like a forest fire or a prescribed burn. And that's because you're doing it in this really controlled environment, right? So under those conditions, in a chamber like that, designed to do that, you have significantly lower emissions. There's still some particulates, there's still some emissions, yes indeed, but it's significantly less than what we all experienced when we had a neighborhood wildfire. So anyway, it's a great demonstration project. It's small, but we're learning a lot, and it's good for our campus and good for the learning side of things. And if the economics would come together in the future, we'd probably be interested in doing a larger one and more. So anyway, that's what I know today, and I have little brochures if anybody wants one later. Some pretty pictures. Thanks.
Excellent. Thank you so much, Stacy. Okay, and last but not least, we have Brandon Weaver here from New Belgium Brewing. And Brandon's going to tell us about the anaerobic digestion process that they use at New Belgium for treating the wastewater from the plant. Thanks so much, Brandon.
All right, thank you for the invitation to come and speak. My name is Brandon Weaver. I work for the maintenance department at New Belgium Brewing Company here in town, and I run the wastewater treatment plant that we've been running since early 2002. Our primary treatment is anaerobic digestion. We are on our second digester. The first one, we quickly kind of went beyond its capacity. We had to upgrade in 2006, so we've been running the current digester since 2006. Our digester is quite a bit different than most of the technologies that we've been talking about here, because our digester is designed to treat a high volume of wastewater with very low solids. So kind of almost the opposite thing we're talking about here. Very similar technologies. It's still an oxygen-free environment. It's still microbes digesting the makeup of the wastewater and producing biogas. But with our particular digester, we had to put in a digester that was designed to treat a very large volume of water. So we needed something very efficient. So we went with what's called a UASB style digester, and I won't get into the specifics of that. But in order to keep the digester running well, one of my jobs is to protect it from a solid waste stream. As a brewery, we have our normal waste streams like office and commingled and things like that. But the vast majority, or the largest waste streams that we deal with, are two different things. We have the solids from the beer making process, which are the largest one is the spent grain. We utilize the grain, we utilize the starches that we're going to convert to sugars and use those to make our beer. But then you're left with a large volume of these grain husks and this large amount of spent grain we need to get rid of. The other kind of solid byproducts we have are our spent yeast. After we use our yeast for a couple generations, we have to get rid of it. And then we have our hop matter, which is a smaller waste stream, but still some solids we have to get rid of. Fortunately, as a business, those waste streams have somewhere that they can go. We have a local cattle farm that takes all of that spent grain, spent yeast, and spent hops. So it does go to a secondary use, and depending, where you're at and your opinions on it, there may be better uses for those as well. But we have a very good source for these secondary usage for these solids. The other big waste stream is the water that we use. Of course, some of the water that goes into our beer making process comes out in beer, but we have lots of cleaning processes. We have rinse waters. We have some waste beer we have to get rid of that create this very large volume of wastewater that we need to deal with, and that's what we're digesting on site at our plant. We still have some solids in that water because the water that we're talking about is mostly our cleaning solutions, the cleaning chemicals that we're using, some sanitizers, things like that. But then we also have the soil load. When we're washing this equipment, when we're cleaning these pieces of equipment, there is, of course, some soil load that we're taking on with that. So we do send some solids into our digester, but it's by and far designed to treat soluble waste stream. Right now, we're treating about just under 200,000 gallons a day. And we measure a thing called COD in the wastewater world, and it's just a makeup of the contaminants or the loading on the wastewater. And right now we're pushing about, even though, as I said, we're not treating a lot of solids, that the makeup of that COD in our water, we're treating about 6,000 kilograms a day. In that 200,000 gallons of wastewater. So there is, a fair amount of, solids digestion going on in there as well. Not nearly like if we were trying to throw, our other solid waste streams at it. But our digester performs very well. It has about a 92% reduction of that loading as we go through it. It is as I said, it's our primary form of treatment. And then we capture the biogas off of the process, and we run it through what's called in the business a combined heat and power unit, or a cogeneration unit. And all it is a large engine with some conversions to the air-fuel mixing. It burns this biogas instead of another source of fuel. And then instead of a transmission, we just have a generator bolted directly onto the engine. We have two engines. One of them is our primary that we run, and then the other, a smaller engine we can use when we're trying to reduce our peak load consumption. But the primary engine is a 500 kilowatt engine. And all said and done, throughout the course of a year, we usually produce about 14% of the overall facilities, the brewery's facilities' electrical demand comes from this waste or this kind of beneficial byproduct off of our treatment. So we get about 14% of our electrical demand out of that. And the reason they call these units combined heat and power units or cogeneration units is it's a large engine, it produces a lot of heat as it's producing this electricity. So we're also able to capture that thermal energy, and we use it for heating water going into the brewing process. Being a brewery, we have a lot of use for this hot water as well. So we're able to also capture some thermal energy off of this process. That's as I said, that's what we've been running since 2006 at the Fort Collins plant. I'm fortunate enough right now to be involved, New Belgium is currently setting up or preparing for our second brewing location. We bought some property in Asheville, North Carolina. We just finished kind of clearing off that land, and we're getting ready to start the earthwork for our second facility out on the East Coast. So through that process, I've been able to kind of go through the kind of design process with some environmental or some engineering firms, and we're looking at technologies we can use there. So just since 2006, when we purchased our current digester, a lot's changed as far as solids digestion, and digesters are becoming more efficient. There are new technologies that are being involved in tandem with these digesters that are going to allow us to keep a lot more solids on site, and so we have less solids that we'll have to ship off site. We'll have more energy creation on site. So what we most likely won't get to the point in the next 5 or 6 years when we're developing this in Asheville to keep all of our solids on site. Spent grain is a whole different monster. The cellulose that's involved in the grain husk and things like that requires a very long, it can be digested in an anaerobic environment, but it requires such a large retention time that we just wouldn't be able to create, we just need too large of a footprint. But what we're hoping to do with the digester we're planning on installing in Asheville is at least not only treat all the wastewater as we're doing here in Fort Collins, but also keep the spent yeast and the hops on site. Once again, as I said, minimizing the solids we're shipping off site and then creating more biogas in the process. So as I said, we're kind of just going over some new technologies, and just in the last year, being able to work on that project, I've been introduced to some new things that have me pretty excited about the future of wastewater, the future of solids digestion, and also more specifically to my world, digestion of brewery waste. And a lot of brewers are becoming interested in that at all different levels, and the technologies are coming along very rapidly. There's a lot of great minds being focused on it, and a lot of new technologies being implemented. So, I think it's just only going to get better out there. So,
Thanks, Brandon. Wow, does everybody sort of get the same impression that I do, that things are moving very swiftly? It's like everybody's sort of mentioned that. This is the point in the discussion where we'd like to turn over the microphone to Gary and Rick. As we've mentioned earlier, we are in the sort of outreach mode, and we're looking for as many comments as we can get from the community. So you've heard some fascinating information. We'd like to get going with some questions and answers. I'm going to turn it over to Gary. Gary, do you want me to, I think maybe what I'll do is bring the notepad a little closer. It feels so formal in here, doesn't it?
The basic questions we asked during the initial presentation, what do you think about waste energy? What would you like to see done here in Fort Collins to pursue that. So, Rick?
So we have these general questions that we want you to refer to, but at this point, since you sit and listen so well, anybody has a testimonial, something you have to get off your chest you want to say right now?
We've been learning about a change in the legislature. Hutch, do you mind talking a little bit? I know that you were sort of involved firsthand in what happened in Colorado, getting the renewable energy credits assigned to waste to clean energy.
So Scott Hutchings with Waste Management. I actually wasn't involved with 252, but I know a little bit about it. So there was a House bill this year that was passed, and the governor did sign to increase renewable energy credits, and one of the pieces of that was pyrolysis was included in that. And so there's been a lot of talk around the state, especially in southeastern Colorado and northeastern Colorado, of some type of pyrolysis facility being built. I don't know exactly who the players are with that, but I think for the discussion today, I think that's what Susie's asking about. That's what I know about it. I really wasn't that involved in 252, but that's the bill.
I had another quick question to follow on the legislation, and that's, I guess, just trying to understand maybe some of the barriers. And are there more or less barriers related to thermal energy or making electricity? And how does what's the city municipal utility? How do they feel about generating electricity versus thermal energy and Excel and all the different players in the area? Who's interested in helping us do the right thing in the best way possible?
So who's going to take that one?
Just a question. I mean, maybe to be recorded.
So
Maybe not a risk. Maybe,
Okay. One very small, I guess, thing to add to that. When we originally put in our co-generator in 2002, it was very new. I think maybe the first one in Fort Collins, so it was kind of untried and untested. And initially, we wanted the ability to feed back onto the grid in case we were creating at that time, our generator was 300 kilowatts. And there were times, 10 years ago where we wouldn't use that on site. Now that would be very rare at the brewery to not be using that. But we wanted the ability to feed it back so we could always be running that generator if we had available biogas. And initially, we weren't allowed to do that. We had to put in very specific blocks and breakers where if we got anywhere close to producing more than the amount of power that we were using on site, the generator would shut down. And there are a couple reasons we never heard an official statement on that, but a lot of the statements we heard were based around safety and saying they didn't want power if there was a dead leg on the power line and somebody was working on it. They didn't want power coming from an unknown source and that sort of thing. As we went further in the process, we got more information that it seemed like it was a little bit more bureaucratic than that, and it was had a lot to do with the agreement with the power coming into town and things like that. But pretty quickly, within the first 4 or 5 years of running that, they changed their kind of stance on that and allowed us the ability to feed back onto the grid, which we have done a few times on Sundays or things where the brewery shut down and we're still running that engine. Certainly not a money maker for the brewery. We get paid very little for it, but we are able to keep that infrastructure running and keep using that biogas in a beneficial way. So we have just in our little piece of that world, we have seen at least that much of a change where this technology came in and it was a little bit unknown and there were some concerns over it, and it seemed like people very quickly realized that would be a benefit more than a hindrance. So that we saw that piece at least kind of improve, and I think even in the last 7 or 8 years, I think that's only gotten much more accepted, and I think we're moving forward in that respect. So.
Thanks. I'm Lucinda Smith with the Environmental Services Department. And so, Stacy, I can't fully address your question, but I can talk a little bit about the Fort Collins utilities and their role and their objectives under the state renewable energy standard. So as a municipal utility, they have a requirement to achieve 10% renewable energy by 2020. And we have several programs underway now to be working on it, which are electricity related. We have we can obtain generated wind power through 2 sites that contribute to that, and we also have a voluntary wind power program, and we also purchase renewable energy certificates, or RECs, part of which contribute to that. So while I think our total renewable energy accomplishment in 2012 is just over 5%, and we're aiming for 10% by 2020, closer to 3.5% is what's eligible towards compliance with the RES because it's not voluntary. When wind subscribers sign up for the voluntary wind program, that doesn't necessarily count. I also know that an RFP was released not too long ago to explore interest in the community to develop some waste to clean energy technologies, and there were a couple of responses, but we haven't followed through on that. So, but I cannot answer the degree of interest in pursuing one direction versus another at this point. But hopefully that helps a little bit.
I'd like to follow up. Karen, you mentioned you responded to an RFP. Could you, right, could you clarify how that happened?
How'd that work out for you, Karen?
And what was
It worked out great. You know, Fort Collins, I watch all the communities, and like I said, I flew to New York City for their, you know, mandatory meeting, and there were 180 people that showed up. But nobody looks at the smaller communities. They all go for the Maui, where the tipping fees are high. They're looking at the ones that are higher. So you're not going to see a lot of respondents for communities where your tipping fee is under $50. That just doesn't pencil out, especially when you're not having 500 tons a day. And so if it's under 500 tons a day and it's under $50, you're going to see very few respondents. But because ours is a modular system, and I know there's the others, I think a lot of people aren't really looking for them. The RFPs that are the major cities have they're in the big publications. You can't miss them. I'm on a service, and I kind of always look, I actually look every week. I kind of look at every state to see if there's an RFP. I type in RFP waste to energy, and that's how I found Fort Collins. And actually, Synagro Biosolids sent me and said, oh, they're doing an RFP because they have large companies that look. But again, the small amounts those large companies are not used to. But I believe it's really helpful because I think even though it might be a 5-year process, it might be shorter, might be 10 years, but it's still a process. But there's more communities like Fort Collins in the United States than New York City, Los Angeles, and
Karen,
San Francisco.
can I interrupt? What I was asking is, you said you responded to an RFP from Fort Collins.
Yes.
Could you give us some information about the RFP for Fort Collins?
Oh, yes.
Who issued it, for what? How many people responded for what?
Two people responded.
To whom for what?
It was for 70 tons a day. I believe there was the proposal was 70 tons a day.
From what organization?
I'd Light and Power, the utility did, and also the waste. They both. It was a combined RFP. So the waste management side and the utility, the Power and Light did. So, but I believe after the submittal, there was only the 2 respondents, and I believe in our submittal we mentioned that we thought that it might not be economically feasible, and so then they thought to rethink it about the volumes.
Where were they going to get the feedstock from? The city was going to somehow flow it to you?
What they were saying was that there was the current amount of waste that they projected was going into a landfill each day at this point in time, as part of looking at that. And that was like about 6-7 months ago. So as part of they're looking at trying to reduce the waste going to the landfill because the landfill only had 15 years left. They were just looking to see if they could explore that before. 15 years comes really fast when you're looking at a project that might take 3 or 4 years to do, and then the selection process. So it was an RFP, not an RFQ, but it was an RFP.
And
Yeah, so the background on that is it was very much of an exploratory RFP, and Karen's right. We didn't have very many respondents, and then one of the respondents, I think, declined at the last minute to continue the process. So the city discontinued that sort of investigatory for now at least. But Karen's right. It was just trying to get some idea of the feasibility. And I don't know exactly if we'll renew that process anytime soon. It was very illuminating to find out that we didn't have enough material, that it wasn't consistent enough. And so I think this is what Karen's pointing out, is that there's, for small communities, this is not quite ready for prime time.
Much of the conversation, both today and in the previous meetings, has been about the economic viability of the solutions. And I certainly understand that option, but if we turn around and look at it from the other view, what it says to me is businesses have the right to pollute our air, water, and food supply until it's economically viable for them not to. And I was wondering if there's going to be any focus on, really stopping the pollution in the first place, stopping the waste generation in the first place, a lot more than, I guess, what I've been hearing in the meetings. Thank you.
That's almost rhetorical, but it's about cheap cost, or is it about environmental standards and safeties? And I guess that's up to the community to draw the line in the sand, how far we're going to go in terms of encouraging consumerism and yet not wanting to violate our environmental system. And I guess my example would be about 5,000 tons a year of diapers are generated here. 5,000 tons. That could be a focus for a digester or a pyrolysis and turn to energy. But my feeling was I'd like to go back to Procter & Gamble and say, redesign that product so that I can recycle it or compost it rather than have it mixed. And so you either put $150 million or whatever, $18 million, $20 million into a facility like that, or you look at some sort of, and I just throw that out as community options as we go down the line, the kinds of decisions we have to make about how we do it, how we live here. You want to respond to that? Yeah, I just kind of set you up on that one.
I have a question. So having like Europe does, like BMW has a car and they do all the plastics, BMW has to be responsible for the disposal too. But like Procter & Gamble, how long does that process take though for having them repackaged? So is it something that's going to be 5 or 6 or 7 years down the road? And do we have to address something now before we have an issue?
No, we sat on the carpet committee on the national level, and I put it out to them. I said, what's cheaper, redesigning the carpet so that you could recycle it, or building a waste energy facility to burn what they wanted to call engineered fuel, which was, and straight out, it was cheaper to build the facility to burn the fuel. But the question to me was, 30 years from now, was that engineered fuel going to be here? I mean, here is a copper sitting on the ground for 30 or 40 years before you pull it out. So the question is, how do you design it now and what happens later? And again, these are community issues. They really are.
I would just chime in, Rick. Karen, you're asking the question, do we need to do it now? So that brings up the timing issue. How urgent is this? And that goes back to what is the driver? And we'd really love to get input from people, what is the driving focus here? If it's the cheapest short-term, low-cost solid waste system, you probably got that now. And you probably maximized a lot of what can be done from what we've seen. If you're trying to address climate change, if you want to conserve energy, produce energy, help with wilderness, do some of these other goals, do something sooner than later, then the cheapest short term may not be the cheapest because the external costs are not integrated into the current pricing of all the services. So I think that's really fundamental to the questions that I'm hearing in this last discussion. So the question of cheap, timing, what are we trying to do here? What is our goal? What are we trying to solve here? We heard about the 10% requirement for the municipal utility. Is this one of the best fuel sources for meeting that need? Might be one of the questions. So, yeah, comments?
Just back to that question, John Anderson, I agree with you. If it's not, or he asked when is this stuff going to be needed or viable, and I'm saying, I'm standing back here going yesterday, 15 years ago, these same problems were there. Maybe not to the extent they are today, but even that much more, it has to be taken care of yesterday and not be counting with money. Because if we don't have that environment, the clean air, clean water, and clean soil, we don't have any of these other economies. It's that simple. Where is the restorative in all of this? Where is the regenerative in all of this? It's not the recycle and recover and reduce. We've got such a footprint, a negative footprint now, the things that we have to do has to be a positive footprint. The bigger footprint we do positively is what needs to be done now, and stop with the bottom line as the only thing that pushes us forward. Because if you don't have that clean air and all those other externalities from manufacturing and of all these unnecessary products, we just won't have a happy place to be, no matter how much beer we can drink.
But I wanted to just ask another question, and I don't think we have the answer today, about the renewable, whether the biogas from anaerobic digestion is considered renewable energy. And I asked the gentleman from New Belgium, and he's not sure that he's getting renewable energy credit for that, if he's being paid a renewable energy rate. It is renewable. Okay. And, okay, so that is, I guess, not a to-do. It's already renewable.
Well, he's using it on site, so if he wanted to do it from a tax incentive point, yes, from federal tax incentive, it would be renewable. But also, it's renewable if he goes to the utility when they're buying it. He can actually go and do that as far as that and get it certified as being renewable. If you just give it to them and don't say it's renewable, they'll just take it. It's up to you to make sure that that's done.
Thanks. I was just going to say, in response to the point that you made, John, I just wanted to mention that the city organization is really interested in improving its work on analyzing the triple bottom line aspect of all major projects. That, I think, gets to what you're talking about, because it doesn't mean that we look at things solely through the economic lens, but that we also look at the environmental aspects and the impacts to society. And we're working on our tools to provide that information in a way that's meaningful for City Council to help them be more informed as they make decisions. But we have a commitment and a requirement to actually improve that process sometime this year and begin looking at the triple bottom line aspect of major projects as they come before City Council even this year.
And many of you have heard me talk about the triple bottom line at City Council before. I know it's widely accepted, but it came out of the marketing industry. Triple bottom line is fine if it had everything, the capital, all capital, that's what it kind of measures. Well, it works fine if you take all the accounting in. It doesn't take the accounting of infrastructure. We keep building buildings that we throw away. The redevelopment of the mall, 20 years. What in the world is that? That and good governance. Governance that's thoroughly trusted by the people. Those are things that are capital that have to be counted in that triple bottom line, but they're not.
Just also following up on the triple bottom line a little bit, as I look at Bruce Hendy's organization, Sustainability, what I notice is he has 3 direct reports, Lucinda, and Joe Frank and Josh Burks. And Josh Burks runs the economic board, but neither Lucinda or Joe Frank directly run an economic board or the social sustainable board. They're one level below in the organization. And the triple bottom line was, touted as a balanced 3-legged stool for a long time. And I think that when you look at the organizational structure, that balance isn't within the organization. And I think that's what also reflects on the economic being more, the bias towards the economic is because the stool's not really balanced. And I don't know if that's just reality is that they're not balanced, or, what we can do about it from that point of view. Thank you.
Lucinda, I just want to chime in on the triple bottom line. One of the key issues that strike me is like the greenhouse gas inventories, phase 1, phase 2, phase 3, direct, community-wide, indirect. And I wonder if you could speak to whether that type of accounting, if you will, is being considered or is incorporated into the thinking here.
Sure, but first I'd like to kind of respond to that question. The City Council has something like 26 advisory boards, and there are several advisory boards that fall under the purview of sustainability services, including Economic Advisory Commission, Natural Resources Board, Air Quality Board, and then there are other steering committees. So just a response to that. The other thing I wanted to say is I don't want this conversation to go too much off track about what the city's doing in regard to triple bottom line analysis, although I very much agree with the statement that John made, that we're learning these tools and the ways to value some of the other values that aren't automatically and easily assigned dollars is something we're working on. But I wanted to say that the Road to Zero Waste planning effort is trying to and will be looking at the triple bottom line aspect of the strategies that are under discussion. And then to respond to Gary's question, we do have a greenhouse gas inventory for the community, and it's actually, it has in the past, for the past 6 years or so, included one element, one wedge you might call it, that is atypical, not traditionally counted in other communities. And it's because we really wanted to get to that life cycle, long-term energy impact of materials. So we have had a piece in our community carbon inventory that talks about the energy embodied in recyclable materials that are currently being thrown in the landfill. And the reason we chose to include that is so that it would match with our climate action plan, which has strategies to reduce, reduce, reuse, recycle. And when you use the WARM accounting system, which has this embedded embodied energy in the calculations, we figured we wanted to avoid that mismatch. Now we are revising our inventory approach a little bit to be in compliance with a newly released community protocol for doing greenhouse gas inventories, so that some of the elements may move into the informational category. But the point is that we have a little bit of the life cycle elements in our inventory, and we certainly recognize the importance of them. And that's why, as you're working on Road to Zero Waste, I think, you know, looking at the long-term life cycle embodied energy is really important.
I'd just like to respond to the community protocol that you're referencing by ICLEI, the group for local environmental sustainability. Just has been issued. We've been working, the industry's been working with them for about 6 or 7 years to get this community protocol done. It's finally out. It's a major step forward. That coupled with the WARM model, which EPA uses as a calculator. If you go to epa.gov, click on search for waste and climate change calculators, you'll get to the WARM model. The WARM model I mentioned earlier addresses the upstream issues. So when John and Michael are talking about some of these other issues, the WARM model is a really key pin to that, and the more we are building on that, the better. WARM does a great job for recycling upstream, not for composting. EPA recognizes they don't address the upstream benefits of reduced water, reduced fertilizer, reduced pesticides that compost application yields, but that's not yielded nationally. It varies by the climate. So they're in a little bit of a conundrum. But they recognize that, but it's still for recycling, which is a huge part of it, it does address that really well upstream. Now with the community protocol of ICLEI, the combination of those two going into the greenhouse gas inventories makes a lot of sense. We've been involved with the West Coast Climate Forum. I'll jot the West Coast Climate, or someone could jot down the westcoastclimateforum.org. They are looking at a systems-based analysis for climate analyses and consumption-based analyses that tie in with the new direction of EPA on sustainable materials management and zero waste. And that's an excellent resource for people to get these broader data points into these local processes. In the work that we did on the West Coast Climate Forum, what we concluded was there's no perfect system out there. Right now, the community protocols and the inventories particularly, the inventories don't do a good job of figuring out what's happening at the local level in a way that translates into action. So the key advice that I'm trying to get to is that local governments should be encouraged to go beyond what the inventory says about how much of your target emissions problems are from the inventory protocol you followed, and go beyond that to focus on the benefits and jump to the action items and look at the effects of those action items relative to your total. So that will help address John and Michael's way of integrating that into the policy framework, which I hear Lucinda working on.
My name is Becca, and I work for Gallego Sanitation. I guess I had a couple of statements/questions. I think they are related to the thermal and the emerging technologies that are happening with the gas and pyrolysis. I had heard, and I would just like clarification on this, when you do have a gasification system, the byproduct, the coal or the burnt product is actually hazardous waste, and so you have to have a very good method of managing that. And so I'd just like to see if that's true, and then also does that same stuff happen with pyrolysis? So now we've got a hazardous material on our hands. Also, my understanding, and if you can correct me if I'm wrong, is there's nothing built yet. There's nothing in place. So all the models we're talking about are just ideas. And really the only things when it comes to the thermal technology are the old technologies, but we don't really have any of these new and emerging technologies in place. So I think being able to look at models, if there are any that are actually in place, and to troubleshoot from them before we invest millions and millions of dollars into these is really important. And I think that's all I had. And then my other statement would be, I guess I'm assuming that it would look like we still have our MRF, then we're doing the composting, and then the waste to energy would be for our discards.
What I know on the thermal is that the ash has been designated in some cases as hazardous and has to have special handling in the landfill.
But she asked specifically
I was going to take it to
about the residuals from the
yeah.
new emerging technologies, and your
Right.
point about we do not have any examples, at least in North America, that we can point to and that we can actually test the residuals, right? So she'll address you about her specific technology.
We actually have had a permitted facility in South Coast Air Quality Management District in Riverside County in 2 places. We actually sold that system. It was moved out to Port Palm Springs in Mecca, California. It should be on in a couple months. But originally when we did our source testing, which was 7 days, we tested the carbon char. We have a char, not an ash. It has an ash content, so it has some ash in it. But we've tested it on a number of occasions with different waste streams, and it is non-hazardous. Now, the ash that he's talking about on mass burn, depending on what you're doing, remember that ferrous metals and all those metals come out with that ash. There is sometimes a chance that you're over, like somebody throws a thermometer with the old style thermometer with mercury in it. You know, that stuff can go into the ash. So they do have regular testing, and it's a matter of, you're like, special handling. It doesn't go into a landfill unless it is non-hazardous, because it has to be tested on a regular basis.
You call that carbon black?
For pyrolysis, it's carbon char, but
Carbon
you
char.
have the ash for mass burn. That's the ash that she's referring to.
Well, no, I understand that.
And then gasification is somewhere in between.
So are there any operated plants in the United States right now?
For pyrolysis?
Yes.
There was. Again, it just got sold. It's moved, so it will be operating.
So there aren't right now?
Yes, there are a few small demonstration plants in the United States. And there are some small gasifications that are pilot size. There's one in North Carolina, and there's a couple of demonstrations. There's actually a small pyrolysis being installed in Hudson for doing tires. Currently, Hudson, Colorado, just down the street. I was there yesterday.
Can you clarify, when you said there are some plants, some small plants?
Yes.
Where are the plants, how small, and is it for MSW, for municipal solid waste?
Yes, we did MSW on the pyrolysis plant in Riverside in Menifee, California, and we did waste. We processed waste from Los Angeles County, Orange County, Riverside County, and we did all our source testing on a post-MRF residual. So it went through the recycling center first, and the residuals that would have gone to the landfill is what the source testing was. All that testing is a matter of public record in South Coast Air Quality Management District.
And that was for 7 days, did you say?
The source testing was for 7 days, but we ran probably about 9,000 hours over a number of several year period.
And the other, you said some small plants and the pilot in North Carolina for municipal solid waste, and what's, how big?
They've done some small testing on municipal solid waste successfully, but it was originally
Where's
designed, Charlotte, North Carolina.
And they did tests or
They did some testing, I would say probably about 3 or 4 weeks worth of testing, but it was primarily for biomass. But it's pyrolysis as well.
for what material?
It was MSW and biomass.
And is that still operating?
Yes, it actually just was relocated, and it's at a resource recovery park. I don't remember the name, but it could be seen online.
Okay, and you said there were some other small plants, other locations?
Yes, American Renewable Energies, they've made some small plants. They have one doing sewage sludge in LA at the Hyperion, but it's doing sewage sludge, but they also built one that did a little bit of MSW.
Okay, the Hyperion is sewage sludge. Where's the MSW?
This MSW, I'm not sure where it was, but it's the same technology, but it's on a smaller scale, 25 tons a day.
On the scale of issue, one of the things that has really been coming through to me is the idea of diversity. That particularly at this stage of activity in this area, it looks like, and with a commitment to a free, open, competitive marketplace, having a bunch of small examples like we've heard about at the wastewater treatment plant, the earth flow composter up at the university, different pieces being shown, different technologies with different feedstocks, earth flow with the manure and the part of the food waste, but they couldn't handle the pulp food waste, but the pulp food waste went down to the wastewater treatment plant's been working fine. So getting the right feedstocks to the right application and technology, not necessarily one central plant. Does anyone have any comments about that as an idea? Does that have merit to be pursued further here?
Yeah, I'm Mark Hattishell, a citizen of Fort Collins. I had a question about the lifetimes of these facilities because I can see a real need based upon the current waste situation in Fort Collins for waste to energy and so forth. But as part of this zero waste plan, it's been emphasized that there is going to be a real stressing of the reduce, reuse, recycle, which seems to me like this discard waste stream is going to drop off over time. But we also heard that these facilities to be viable need like long-term contracts to have a steady waste stream to be profitable and so forth. So those seem to be somewhat in conflict with one another, that if you're going to guarantee the long-term stream, then that works against the efforts to reduce the production of that waste stream. So are we talking about facilities with fairly short-term lifetimes, or how is that being brought into the whole planning process?
I can address that to a certain extent, then maybe you guys have some other thoughts. But in terms of the lifespan of these technologies, a lot of the equipment, there are tanks, there are tubes, there are dials, there are things that would need to be replaced and repaired over a period of time. When you are financing a large $500 million facility, the time frame is really about the fact that you need to amortize those costs over a long period of time and over a lot of tons. So that's why, when you're looking at expensive solutions, having more tons over more time, that's really the issue about the time frame. The actual tanks and tubes and flares and things, those are on a maintenance schedule. I'm not sure if any of the the big waste to energy facilities in the U.S., is it kind of like George Washington's hatchet? I mean, over time, things get repaired and replaced and refurbished. But a number of these plants, these older plants that have been in place for 20 and 30 years, a lot of the infrastructure is the same, and they've been amortized over 20 years. A lot of them have now renewed their contracts for another 20 years. So they were paid off in the first 20 years, and now a lot of those waste management authorities that got into those long-term guarantees are looking at a reduction in their tipping fees because they've already paid off the major components and now are either now paying off for the refurbishment and replacement costs or the upgrading costs or other costs. So, but the technology itself, you know, it's not mysterious. It's, you know, pieces of equipment that degrade over time and must be replaced. So I think when you're talking about timeframes, you're talking about amortizing the whole construction costs, the site acquisition, the permit costs money. You know, there's so much that goes into those very high costs. I don't know if you guys want to address costs in any other way in terms of term.
Ruth, where was that you were talking about? The plant's been operating 20, 30 years. Where was that?
Here, that's right.
86 plants in North America, in the U.S. You know, some of them were cited as long as, you know, the mid-'80s to the mid-'90s. Right. Those plants are still in existence, many of them, and many of them are now paid off, and now they are renewing their contracts, and in some cases, those waste management authorities are reducing their tipping fees.
But also, isn't it true that in other locations, they've had to upgrade, they were facing with the contract renewal additional upgrade costs to meet current environmental standards?
Oh, absolutely. And then a number of these plants over even the first initial 20-year term were upgraded for new pollution control devices and other things that had to be paid for. So the facility is a dynamic facility. And if you think about it in terms of other major infrastructure, the wastewater treatment plant, you might have a wastewater treatment plant, you know, that's 50 years old. Some of that infrastructure is 50 years old. Some of it is new. And a lot of our infrastructure is aging, and we need to be looking at replacement of some of those things over time. A lot of these plants are just like any other industrial facility. They degrade over time and need to be repaired. That's all taken into consideration. But the commitment of tons, you know, if you had $500 million check, you wouldn't have to have a 20-year term. So that's kind of the issue of that amortization schedule and why we have those lengths of terms. It's not directly related to how long the facility will run from a practical standpoint. You know, a lot of these facilities, you can keep retooling them, run them forever, but some of the, you know, it requires the maintenance, it requires replacement of parts, it requires, you know, a lot of other things. Did you want to say anything else about term?
Yeah, because you're right. The waste contract does have to match your financing. Your bank or your institution or your money isn't going to give you the money to pay it, the $13, $14, $15 million, unless, so you've got to say, this is how much your waste has to be for the next 10 years so that you can pay that off. So it's as simple as that. So you're right. So if you have a decrease, there's some projects that had a county that was going to bring stuff to a landfill. There's 2 projects that got canceled on a waste to energy because one city pulled out their contract, so now there's not enough waste to make it economically feasible. So it's directly related.
The mayor of Hilo had to put a resolution to kill all the recycling programs so that he could get his 300 tons per day. It didn't happen, thank God, but because they have a great program. So that, you know, a lot of these burn plants didn't make their tonnage, and it's a put or pay.
My name is Caitlin. I work for the city. I've also lived here in Fort Collins since 2005. My question kind of brings it back to the basics. So if our community is really trying to achieve a zero waste, I feel that there's some areas that haven't necessarily been focused on, which will help achieve this. One of them being the city requires waste companies to provide a free service of recycling to residential properties, but they don't require it for apartment complexes, for condo complexes, and for businesses. And I feel like in our community, this is a big aspect of properties that people live in. You know, we have a big campus, we have a lot of kids living in apartment complexes, and if they want the opportunity to recycle, they actually have to collect their own recycling and bring it to the landfill or up to Riverdale. The reason I've heard in the past is that they feel that these type of organizations and locations don't understand recycling enough, so they won't necessarily be recycling the proper things, and there'll be too much waste going to recycling locations, and then that will actually then just go back to the landfill. So my first question would be, how does the city plan on approaching this, getting those type of organizations and groups engaged? And then is something in the future going to be looked at maybe requiring apartment complexes and condo complexes and businesses to all have that option to recycle?
So your question is, and we want suggestions from you, but what I'm hearing, what you're saying is that you'd like it to make the rule here in Fort Collins that everybody has to sort of separate for recycling, including your businesses and your apartments.
Not necessarily the rule. I'm thinking that it makes more sense to make sure that that opportunity is provided, that every apartment complex and every condo complex and business is going to have recycling, and it's up to them to get involved and, you know, have programs to get people actually engaged around the concept. Because I also work for the Parks Department, and I see recycling and trash containers right next to each other, and oftentimes you'll have more recyclable items in the trash, and I think it's a lack of responsibility. Some people don't necessarily feel that them recycling something is actually going to make a difference.
So that's it. My son works for the Parks Department in San Diego, and we have this battle with the city to get the city to help them do the recycling of the green material. What would you suggest this plan deal with when they talk about city departments like parks and libraries and how they participate?
Oftentimes, I've found that signage really helps. Right now, you'll have containers that just say recycling and then trash next to it. It's great when they're next to each other because then it makes it a lot more convenient. Hey, why do I throw something in the trash when it's right here? But when people don't understand that the little things that they do actually make a difference, so somehow figuring out how to reach out and start at the younger ages, start with the kids in school, have them get their parents involved. Even getting the workers for the city, making sure that, you know, they're verbally talking with people, or having signs that, you know, say recycle this, trash that. Currently, there's no type of educational visuals for people when they come up to a recycling container.
Okay, good stuff. Susie?
Great. I think those are really great comments, Caitlin.
Yep.
Thank you very much. And I think we could add these comments into the mix of things that are going into this plan, because I think it absolutely has to be addressed. Thank you.
Yeah, we just talked about the economic model. That's what got us into this environmental mess in the first place. It has to be abandoned, in my opinion. That's until we start changing how we finance these kinds of things. It's a mortgage on our future, meaning mortgage being death on our future. We have to take it out of the hands of the bankers and those kinds of things and put it into our hands of how this is a dedication that we have to pay for the rest of our lives if we're going to keep producing as a community these things, or allowing those things into our community that we have to deal with. It's the externalization of all the materials that come in from the manufacturers, basically.
Back to the question of being short on tonnage for some of these processes. Do any of them allow us to mine what's already in the landfill to make up for that tonnage, or is that material no longer viable for any of these processes?
A good example is our Fort Irwin project, but they handle their waste a little different. I've never been to one that actually puts it in big super sacks. They have been storing trash for the future for energy. They actually bale it and put it in super sacks and stack it in the landfill. So it's easy to landfill mine that type of landfill. Another landfill like you're doing where you have gas already, so that one's been, they're flaring. You have to be very careful when you're doing landfill mining. You probably can go down a short way, but if you're doing landfill mining for energy, you've got to be careful about how you approach that, because there's a lot of pockets of gas in there. So it's not as easy as a lot of people say, oh, you can landfill mine. It has actually got some hazards to it, so you'd have to be extremely careful, but yes, you could. It's just a matter of how you can do that. But that's what we're doing at Fort Irwin. On days when they only have 22 tons of trash and we need to have 30 to make their energy quota, we're going to take the bales, which are equivalent to about a ton of trash, and take those bales out, and we're going to reuse that they did several months ago.
Oh, I know a landfill in Georgia's just got baled carpet ready for you.
Yeah, I don't want to get into a long discussion about
Name,
this.
please.
Oh, Mark Howdeschelt. But I used to work with the cement industry in Mexico, and one of the big things they were looking at for reducing their greenhouse gas emissions was using municipal solid waste as a fuel in their cement kilns because they use some of the dirtiest fuels currently, like pet coke. I noticed that was mentioned in some of the slides, but it hasn't really been discussed here, and I was just curious if that is being considered as one of the options, or if there are disadvantages to doing that versus some of the things that were discussed.
And I can also take a track at that as well. So there is a trend, and there's a big interest on the part of cement kilns in looking at alternative fuels, and refuse-derived fuel is something that they are very interested in. Many state legislatures are looking to allow cement kilns to use refuse-derived fuel or other feedstocks, such as whole tires or tire-derived fuel, for their energy needs. The concerns on the other side is that a cement kiln is not regulated the way a waste-to-energy facility is regulated in terms of air pollution control. And some of these plants are older, and so a concern that a community might have is that if you are switching to a fuel, especially to a mixed waste fuel that is inconsistent in its material, going from even a dirty fuel like you mentioned to a mixed waste fuel, there would be issues, there would be concerns that folks would have. But in terms of everything being on the table, everything's on the table. And so the one question would be, what cement kilns are in the area? What are they currently using for fuel? What is the alternative for producing a fuel that they can then use, which would also take money and cost to produce that fuel? And then, what would be the impacts, environmental impacts associated with that? And that would have to be taken into consideration in decision making.
I think this conversation could go on for quite a long time, and we won't have gotten to what I love about this is that it started a very important conversation in this community. I think people should be attentive to opportunities to learn more. Is a workshop being sponsored by the Colorado Association for Recycling on September 11th, and more information would be available at cafr.org. So, here we are on the road to zero waste. This is certainly a great start to this conversation. Much to learn in months to come and years to come. We've got an online opportunity to provide comments. We are, as you can tell, Gary is diligently writing down every last idea and comment, and we invite more.